Okay, so this is the recording for the notes for 11.3 areas of circles and sectors. Our essential question today is, can you find areas of circles and of sectors of circles? And so I think you'll find this is pretty straightforward. We've done perimeter of circles in the last chapter, and we also did like the arc length, which was a piece of the circumference. So when we do areas of circles, it'll be just that area of formula you're used to. And then sectors will be like a piece of that or a piece of pie. Today you're writing homework 3. Tomorrow homework 2 is due, and homework 3 will be due on Wednesday. And I will be giving out handouts for this section right now as people are writing the essential question and the heading for the notes. So 7th hour, hopefully the teacher can give those out as well. This will be just a running time. If you do need to pause the recording to write something, you can. Otherwise, I will just be letting people write things as we go. Okay, so by now everyone should have written the heading. This is 11.3 areas of circles and sectors. And then we'll be looking at some things. We have a key terms section. I'll put that up next. Everybody in the class that I'm talking to right now has their 2 handouts, and we'll look at our key terms. What you're defining is the segment of a circle, and the segment of a circle is actually the region bounded of a circle bounded by an arc and a chord. So it's that little blue spot there. And so that's a unique, maybe that's a little bit new for you. The shaded region is the segment of circle A. And then you're also defining the sector of a circle. That is the region of a circle bounded by a central angle and its intercepted arc. And then just a reminder, vocabulary about central angles. You decide if you're going to define a central angle and an arc in this key terms. They were just in chapter 10, so that was fairly recently. Central angle is an angle with a vertex in the center of a circle and with sides that contain 2 radii of the circle. An arc is a portion of the circle defined by 2 endpoints. So I'll let you write those reviewed key terms if you would like to have those definitions. Otherwise, I will have you just write the segment of a circle and the sector of a circle. Okay, so we should have defined those parts. Just a reminder, the 3 main points for the sector of a circle, the x degrees of that central angle, we have to either know or know something about that, the radius r, and then a standing for the area. So on your small handout, you have 2 things. The area of a circle is equal to pi times the square of the radius. Just be careful that you square the radius, then multiply by pi. Don't take pi times the radius and then square that, or you're also squaring the radius. So that one should be pretty familiar to you and in your kind of repertoire of basic area formulas. Then the area of a sector, and the one that we're going to use is the one I have the little box around. So the area A of a sector is the area of the whole circle, which is pi r squared, or excuse me, to the area of the whole circle, which is pi r squared, is equal to the ratio of the degree measure of the intercepted arc x to 360. So a divided by pi r squared is equal to x divided by 360. And so the equation that we get is a equals x over 360 times pi r squared. This is something that you should put on your half sheet. I'm telling you that right now. You know, certainly this one also, if you don't remember the area of a circle, but this one for sure. And just to let you know, we will do this in terms of the central angle, but sometimes we'll know like a fractional part of the circle. That is also going to work as we go through this, and I think you'll see that as we do the couple of examples that we have today. There are not a lot of examples for us to do in this section, and we should find that it is pretty straightforward. So here's our first one. I'll read this to you. An outdoor accessories company manufactures circular covers for outdoor umbrellas. If the cover is 8 inches longer than the umbrella on each side, find the area of the cover in square inches. And so we know that the cover's diameter is 72 inches, but then there's this little extra 8 inches right here, and then that means there's a little extra 8 inches right there as well. So the diameter of the cover, so I'll just write cover diameter is equal to 72 plus 8 and plus 8, or plus 16. And so the diameter is equal to 88 inches. And if you remember when we first started talking about circles, I said always figure out what the radius is and write that down, because most of our formulas that we use are in terms of radius. So the radius we know is 88 divided by 2, which is 44. And then we are to find the area. One thing I'm going to say about finding area is if we're asked to find the exact area, we leave pi in that. And so just as a formality, I will be giving areas in terms of pi first, and then figuring out what that is using a decimal. So area is pi r squared. And so pi times, in this case, 44 squared. And so when we square 44, tell us what you got there, Jason. Before pi, just what is 44 times? Okay, 1,936 pi. And since this is in inches, we'll say squared inches. This is the exact answer, just to kind of let you know. Then when we multiply it by 3.14, we get an approximation. And Jason, since I know you have that, tell me that to the nearest whole number is fine. And did you use the pi key? Okay, using the pi key, that's what we get. I think it's a little less using 3.14. Nolan, will you just take a minute and use the 3.14 and tell me what that is? And so 6,079 square inches is what you get using 3.14. And I'm just writing that for this first one, just to remind you when you take quizzes and tests, I personally will figure it out using the pi key and using 3.14, so I would accept either of these answers. When you're taking a test, if it's a multiple choice problem, only one of these would be on the test, and nothing else would be as that close to that answer, so that you would have to be careful of that. So just to kind of let you know. Then our next problem is one where we have to find the radius, and we know that on these problems, in each section, we've had the area sometimes and had to find missing parts. The only other part we have is the radius. So find the radius of a circle with an area of 58 square inches. So area is pi r squared. 58 is pi r squared. Excuse me. So for this one, we're going to divide by pi on both sides. Really, I'm going to do this a little different than sometimes we have. I'm just going to leave that as 58 divided by pi for a few minutes, and then I'll just type it all in at the end to get my final answer. So this is r squared, which is equal to 58 over pi. And then to get what r is, we're going to take the square root of both sides. So I'm going to write this up over here. R equals the square root of 58. Oops. The square root of 58 divided by pi. And that gives us a closer to actual answer when we kind of wait and put it in like that. And I want this one to the nearest tenth, which is 1 decimal place. Colin, when you have that, tell me what it is. 4.3. 4.3 inches, since we did know it was square inches. And did you use the pi key? Yes, using the pi key. I believe in this one that it's the same to the nearest tenth using 3.14 as well. So that's kind of the basic idea of what's happening here. The next one is a sector problem. And pi has a diameter of 9 inches and is cut into 10 congruent slices. What is the area of one slice to the nearest hundredth? And so I will kind of underline to the nearest hundredth just to kind of remind us. And the diameter is 9 inches. So I will write diameter is 9 inches, but then right under that I'm going to write radius is 9 divided by 2, or 4.5 inches. So just a little reminder to make sure that I have that. Now, I think you'll find something that happens in this particular case, but I will always do this in terms of the central angle. So without drawing 10 pieces, I'll just draw kind of one piece, whatever that looks like. I'm getting 10 congruent slices, so I know that all the way around the circle is 360 degrees. So to figure out what my central angle is for each slice, I'm just going to take 360 divided by 10, and so that's 36 degrees. So that means this angle is 36 degrees. And, you know, if you're kind of thinking this through, you'll see that something else happens there as well. Let's write the measure or the formula for the area of a sector. The area of a sector of a circle is equal to x divided by 360 times pi r squared. So really that's very like the arc length formula that we used before. And here our angle is 36 degrees, so we'll take 36 over 360 times pi times 4.5 squared. And what I want you just to notice here, oops, let me go to this, is there were 10 congruent slices. So do you agree, give me a head nod, that this is 1/10, right? If there are 10 congruent slices. And then look at our angle fraction here. 36 over 360 is 1/10, correct? And so that is another way to do this, is to think of that it's 1/10 of that area. But I will find the central angle just to kind of let you know as we go. So take a moment, type all that in on your calculator, and see what you get as an answer. We want it to the nearest hundredth, and both with pi and 3.14, it'll work out to be the same. And I'll give everybody a moment to do that. In the hour that I'm recording, I will be looking at your calculator to see what you have here. So you'll hear me say yes a bunch of times. Yes. No. Oh, times pi. Divided by 10. Calculator. Yes. Oh. And then you have to do this part, or this part, times that, divided by that. Yep. Yep. You have to do a little more to get there. Yep. 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 Yes. So if you've done this carefully on your calculator, and my suggestion is just kind of go right through this. You can use your calculator to take 36 divided by 360 times pi, times pi times 4.5 raised to the second, or squared. And if you type it in just like this, you should get the right answer. It is 6.36 inches squared. Squared inches, yeah. Just to kind of let you know. And you should have gotten the same thing using either the pi key or 3.14. Now, really, that is this lesson. Pretty straightforward, pretty short. Homework 2 is due tomorrow. Homework 3 is due Wednesday. You should have lots of homework work time. I will stop this recording, and my expectation is that everyone is working, and I will see you tomorrow.